back in 2018. And the requirements of that $5 million grant, the grant itself, we are required to match that grant with funding from universities, private or public sector, other non-federal sources. So that's how our model works, and that the research that will be presented today is all founded and operating under this model. Next, please. So just a bit about our impact. We've, as said, we've invested over $10 million. We will have invested over $10 million by the end of this year. We will have performed 30 collaborative research projects since our launch in 2018. And again, the 4 projects that we will be sharing with you today are all part of this impact. 45 contributing private and public sector organizations, which I'd love to mention or run through, but we don't have time for that now. But I would say, if you visit our website, irrigation.org, you can find out more about our activities, etc. And of course, I have to have the pitch for being a member or research partner. If you're interested in that and you're not already, contact me. And there's my email address, timothy.martin@collegestate.edu. So be happy to talk to you. Next slide, please. So today we are presenting the 4th Be With You, aptly and very creatively named and concocted by our Susie Hutton. And we're very happy to be here on this day. These presenters we have: George Oamek from Headwaters, Charles Hillyer with Fresno State, Trenton Franz from Nebraska, and Dayle McDermit from the Nebraska Water Alliance. These folks have been working with us and we with them for the last, at least, well, the projects they will present in the last 2 years. So we're very, very happy to have them here today. And I think I will go straight in to George Oamek. I believe he's up. Is that right, Susie?
Yes.
My name's George Oamek. I'm with Headwaters Corporation. As you can see, I'm not with one of the affiliated institutions, but I am with the Platte River Recovery and Implementation Program, and we do have relationships with the irrigation industry. And then I'm also a loyal green and gold alumni of CSU, so that must count for something here. So and we're going to talk about the economic impact of the irrigation equipment and services industry. That is, this presentation is going to deal with dollar signs, maybe more than acre feet or other sort of technical units. So everybody relates to dollar signs, and usually everybody has an opinion. So I'll look forward to hearing everyone's who wants to volunteer those. The effort was conducted for the Irrigation Association and was partially funded by the IIC, and we're grateful for those. And if John Farner's on the call, he was with the Irrigation Association at the time and was tremendously helpful on this project. So I'd like to call his services out, as well as Amy Cremens from the IIC. So thank you both. Next slide, please. And I'll be brief, and we're going to get right to the point here because methodology kind of gets boring, and I'll try to set a quick pace and hopefully succinctly. The scope of work for this study was to estimate the dollar magnitude of the irrigation equipment and services industry. That is, how much money is spent on center pivots, drip systems, delivery systems, pumps, services, the whole package within the U.S. Annually. And by the way, it was an independent update of a 2010 study that did the same thing, of which I worked on, which I guess made me the initial person to contact for an update of it. And you would think that I would have just updated the study, but no, we had to start all over again because we really wanted to maybe look at a different methodology to do it because of a lack of data, which I can't go into because of time, but we wanted to do this independently and see what happened independently of the 2010 study. So what were we measuring? Well, we're measuring the direct impacts, the expenditures for irrigation equipment and services at the national level. We include imports and exports, but we don't try to, it's not precise that way. We also looked at the indirect and induced impacts. These are the so-called multiplier effects of these expenditures to kind of see what's the impact of the industry itself and the supporting industries as well. Next slide, please. And why did we do this study? And the first 2 points I'll make were at least where I was thinking walking into this. We want to measure the growth over time of the industry, how big it is, and we like to, and that's a good way of knowing what the political clout is, or the lobbying power is. You know, how big the industry is. You know, something directly related to how much attention you may get at a political level. You know, more powerful lobby for the industry interests. But as conducting this, and what I've been kind of better appreciate, that there's other uses for this study that are probably more valuable than the first 2 measures. And that's manufacturer and supplier benchmarking. As you know, this industry is dominated by firms, not dominated, but is strong presence of firms who are private firms and who don't share a lot of information for good reasons, I suppose. And also information for investors and creditors. By not knowing the size of the industry or the market shares of certain firms and certain products, it's not helping bring money into the industry. That is, if you do want to raise capital, maybe a little bit more information about the industry would be useful. Then this is a very small step in that direction. Next slide, please. We'll get right to the results here, because who wants to talk about economic methodology at lunchtime? But you can see that there's a bar graph here, and you can see the figures are expressed in thousands, but it's actually in that's how many millions there are. So you can see the first bar is the crop irrigation expenditures at approximately 2.4 million, 2.377. That's our estimate of expenditures in 2020 on stuff like center pivots, gated pipe, stuff that irrigates crops. And that also includes delivery system expenditures as well, Rubicon gates, things like that help facilitate those things. Again, it's not a precise estimate, because we round it off into millions, but an estimate nonetheless. The second bar is what we've estimated to expend for residential and commercial equipment. This is decidedly non-crop. I mean, this is for landscaping, basically, to support. And we've just estimated that it was about 2.3 million, something very close to what's spent on crop irrigation is spent on residential and commercial equipment. It's kind of an eye opener for me, because I come from an ag background. But also the thing that also adds to this equation is we also associated with the residential and commercial irrigation, the landscape, is we have a huge support industry, which includes both a retail chain that goes along with that and markups associated with that. And then also there's a lot of landscape services that install equipment and maintain it. So if you add the 2 up, you're looking at a component of the industry that might probably bigger than the crop side. So it was kind of a bit of an eye opener to me. Then the remaining 2 bars look at smaller components of the industry, the landscape and horticultural equipment industry, and then also we look at net exports. So next slide, please. This puts into the table the information from the previous graph, but then also compares it to 2010. And anyway, we can see how we I won't just read off the table, but you can look at it and see what the numbers are. And then the final column represents compound growth over that time, not total growth, annual compound growth, which is how us economists view the world, I suppose. I would probably draw your attention more to the final numbers, the bottom lines, in the sense that we've estimated a compound growth rate of the equipment industry of 2.3% over time. The fact that it seems to make sense is good, of course, and it's mildly surprising in a good way that we could look at 2 different methodologies and come up with results that seem to be consistent over time. That said, I would hate to put too much faith in the industry specific ones, just because we are using somewhat different methodologies. But the growth of 2.3%, I will confess, it did meet some of the industry's preconceived notions of what they thought it was. They looked at in 2010. They were kind of coming off the bottom of the Great Recession, and things seemed to grow pretty well over between then and 2020. And we estimated at about a 2.3% rate. Next slide, please.
Could I clarify something, please? Yeah, is that the units in that previous slide or what? Just to make sure.
Okay, they would be in millions.
Okay.
So the 7-point-something billion for 2010 and 8.9 billion for And those are direct impacts. Those don't include the multiplier effects. So
right here we are with that. Thank you.
now we have the multiplier effects. So we've put those out graphically, and you can see that the multiplier effects, exceed the direct effects. And then we line it up for crop irrigation, for residential, commercial irrigation. That includes the service component of it. And then we add the two for the industry. And you can see from an output side, the industry comes up to just shy of $25 billion in economic impact to the U.S. economy. Not an insignificant number. Next slide, please. How does that translate to employment? Let's go to the bottom line here to keep this thing moving. But we've estimated that it accounts for over 160,000 individuals employed on an annual basis. That's over the United States. Of course, they're probably distributed unequally across the United States. So next slide, please. Again, this puts those numbers in perspective in a tabular format, and it just compares 2010 to 2020. And you can see that the 2.3% growth rate we looked at in direct expenditures follow in the indirect and induced expenditures as well, mostly because we are using a linear relationship through the multipliers. But you can see it comes up to about 168,000 employees can owe their jobs in some form to the irrigation industry. Next slide, please. Conclusions and summary, and then I'll discuss lessons learned. And these are always, the most fun parts of these studies, because it's kind of where you really try to define the value you have. But of course, some of these points we've gone over. Industry has grown at an annual rate of about 2.3% compound annual rate. The current estimates appear to agree with empirical data on the crop side anyway, that what you got out of the 2010 or 2018 Farm and Ranch Irrigation Survey, or whatever it's called now. But we were using the surveys to kind of calibrate every 5 years. And so we have some agreement on the crop side with that. On the industry, we're depending a lot on anecdotal data here and what the industry's own perceptions of what their numbers are. That's a study in itself. And I think it's causing one of our, it is the source of one of our major recommendations coming up. So, but anyway, bottom line is we didn't have a lot of data on the commercial and residential side, just because a lot of the equipment comes from private companies. So third point, pandemics are bad. Of course, we did the study during the COVID-19 pandemic. And so of course, we thought at first we were going to see some really dramatic impacts to the industry. I think the dramatic impact of the industry was it's actually on the positive side, as it turns out, because it turns out the pandemic kept a lot of people at home, not traveling and not going out to restaurants. They used that additional disposable income to spend on landscaping, and of which irrigation is a component of that. We don't have a lot of empirical data to back that up yet, but that seemed to be a predominance of anecdotes we were getting from people in the industry. So crop side too, crop prices have been very high in the last 2 years. The irrigation expenditures are driven by variables out of the industry's control generally, crop prices and new construction. That probably doesn't come to a surprise to anybody, but right now, if you notice it, the price of corn is over $8 per bushel, which is about 2 to 3 times its norm. It's not hard to look at good years coming for those people selling crop irrigation equipment. There's no evidence of water conservation initiatives reducing demand. This kind of comes back to some work we were doing in the Colorado Front Range, where we're looking at things like turf replacement and whether that would reduce it. And again, this is a lot of anecdotal data at this point, but it looks like some of the water conservation measures still require irrigation. They don't require as much volume of water, but they do require at least as much precision and associated equipment. So I don't know if there's anything to fear from water conservation on the irrigation side. It's just maybe a different kind of equipment. So next slide. If there is a next slide, lessons learned, I think, and I can wrap this up. We were hoping to regionalize this model to be able to look at a lot of other explanatory variables, like operator age and demographics and things like that. But when we looked at a national level, a lot of the stuff gets washed out. So I think improving the model would be to regionalize it would really be cool. We do have geospatial tools exist that might estimate our irrigated turf areas, which is something we kind of had to guesstimate at, I guess, but we didn't have the resources in the project to really exploit those geospatial tools, GIS stuff. And it's kind of spotty throughout the West in areas. Big conclusion, there's no substitute for empirical data. We found anecdotal evidence is very valuable, and especially when it comes from the industry itself, but it sure would be nice to back this stuff up with empirical data, and then your statistics would have a lot more meaning, I guess. Moving forward, and this is, I think, our biggest recommendation, there is a need for a process for collecting industry data while maintaining some anonymity. I, off the top of my head, don't have a method to do this, but I think to do this study a third time in 5 or 10 years, if you want to update it, it would, I don't know if we would gain a lot unless we had a way to get better data. So that's maybe my biggest lessons learned, is there's no substitute. And with that, I'll open it to questions for whatever time we have. So for that. So.
Yeah, we have time for 1 or 2 brief questions from.
Well, pick the easiest one. Yeah. So
I see some folks talking, but maybe you're on mute. Not sure. Speak up or raise your hand on the chat, whichever works for you. George, while we're looking for that, the things you were talking about there at the end, I think, are quite interesting. And since you're an economist, you have to make predictions about the future. So we can blame you and your compatriots when it doesn't come true. But what is it that you see? What do you think is the trend? I mean, you've got a solid trend in 10 years, but a lot is going on. You mentioned some of them, the municipal water restrictions. You got persistent drought, at least in many parts of the West. We've got new technologies coming in that are rapidly infiltrating or being adopted in the industry and by users. What do you see, all those factors put together? What do you think is going to happen with your study in 10 years when you come back?
Well, first, as economists, we always have to make predictions. For some reason, scientists get out of it, but economists, they always try to hold us to these things. But I'll say on the crop side, I would be very optimistic, I guess, because we're looking at strong crop prices now. We're looking what seems to be a backlog of demand for irrigation equipment, at least in my part of the country. I don't see, given macroeconomic events and international events, I don't see demand backing off much for a while. And I see crop irrigation becoming increasingly used in areas that are currently not irrigated as a form of crop insurance and increase yields. $8 a bushel, it doesn't take long to pay for an irrigation system. I think as water restrictions become more prevalent, water allocations for crop, I don't know how you could not be optimistic about the demand, I guess. So especially with strong crop prices. On the residential commercial side, I would be somewhat similarly optimistic, because as water becomes increasingly scarce and housing becomes increasingly expensive, landscape is an important component of the value of your housing. And I don't see people scrimping on their landscaping, in the sense when you put $20,000, $30,000 into a xeriscape landscape, which I'm now hearing is way on the low side. You're not going to let it die off the first few years for lack of water. Yeah. So you're probably going to make that additional investment in an irrigation system. That said, there may be places that are currently irrigated, may not be. But anyway, I always being an economist, I have to recognize the other hand. So there you go.
Right.
So.
Well, thank you for that, George. There's some questions and so forth in the chat, and we'll manage that after the session as well. So let's go to the next speaker, Charles Hillyer. And Charles, just get away. Thank you very much.
Thank you. So this project is, as you can see from the title, Closing the Loop on Sustainable Plasticulture. This is a partnership between Fresno State and Jane USA. Jane is both an IIC partner and is providing the matching funds for this project. And I'll explain a little bit more about what I mean by closing the loop. Next slide, please. So U.S. manufacturing, or the U.S. irrigation manufacturing industry produces about 250 million pounds of plastic products. And about 100 million of that is single-use plastics. And unfortunately, only about 10% of that actually gets recycled. So there's a sustainability issue here that we want to address, right? There's also, interesting, a distinction between single-use plastic and long-term plastic. Now, if you work in the irrigation industry, you're probably aware that the thick wall drip tubing stays out in the field a lot longer. And single wall drip tubing will get used for one crop, maybe two. It's not in the field for more than a year, generally speaking. So there's some pressure on both the manufacturers and the growers to become more sustainable in all aspects. And there's an opportunity here to make single-use plastics more sustainable. And that's what we mean by closing the loop. We are proposing to do a project to study both the economic and technical feasibility of taking single-use thin wall tubing and remanufacturing it into long life thick wall tubing. So this plastic gets recycled and actually stays in the ag space. So that's a sustainability benefit both for the manufacturers and the growers. Next slide, please. So there are a couple of existing recycling programs. One is the NetFM Regen program, which has been around for a little while now. Another one that's been around for quite a bit longer is the Delta Plastics. So recycling programs aren't a new thing, it's particularly in the irrigation space, but they've had somewhat limited impact. They tend to be associated with one particular manufacturing facility or one particular, in the case of Delta Plastics, one particular type of technology. The obstacle here is that virgin plastic is valued at 60 to 65 cents a pound. Since these slides were prepared, I know that price has gone up a bit, but it's still substantial. Substantial in the fact that virgin plastic is still very affordable. And Jane did an economic investigation a few years ago and found that a viable economic scale at the time would have been about 200 million pounds of recycled product a year collected. And the transportation costs were the major, probably the most significant factor. On the technical side, the problem is that this used tape would, by mass, contain 30 to 50% of non-plastic material. So there's a technical challenge associated with not only collecting and aggregating this equipment, but processing it back into something that's viable and will produce a quality product. Next slide, please. So the goals of this project are to investigate both the economic and the technical feasibility of using thin wall single-use drip tape and remanufacturing that into thick walled or long life drip lines. There's three facets to this, or three specific objectives. One obviously is the economic feasibility study. That is going to focus on both a market survey of current cost drivers as well as an enterprise budget. The goal with the enterprise budget is to produce something that could motivate small to mid-sized startup companies to initiate a new recycling enterprise. The second objective is to perform some fairly exhaustive laboratory testing of this remanufactured product. So Jane and Fresno State have partnered with Dow Chemical to do some materials testing. And then the Center for Irrigation Technology will do a battery of tests on the remanufactured product itself. And then the third objective, which actually runs beyond the lifetime of this grant, is to initiate a long-term demonstration and monitoring of these drip lines for recycled products. A product that's meant to last 10 to 20 years would require 10 to 20 years of evaluation. And we have a unique situation at the Fresno State Farm where we can do that. My next slide is about the economic feasibility study. For that study, which has already started, we're going to be looking at the main cost drivers. That includes both power, capital expenses, water treatment, and transportation. We're going to be looking at operational scale. So how big would this operation need to be in order to be a viable business? That one's particularly important in the enterprise budget because we are trying to incentivize or provide the economic information that would incentivize creation of new small to mid-sized businesses that are inherently regional. And the last bit of that is the freight and logistics. That in the previous study was one of the main cost drivers. And so we need to have a thorough understanding of what those cost drivers are and an updated set of costs for them. So this project is very much in progress and there's been some delays. Next slide, please. So just to be completely transparent, there are some administrative delays. So this project is behind. Those administrative delays are entirely in Fresno State's court. So this isn't a problem with IIC or Jane. We've had some turnover in Fresno State and things have been running really slowly. However, we have made some progress. The preliminary enterprise budget is completed. Dr. Serhat Oski has been working very diligently on that, and he is ready to commence the market survey. So we'll be contacting Netafim and Delta Plastics, as well as several local recycling enterprises here in the San Joaquin Valley. Next steps are for material, go back one more. Next steps, as we mentioned in the objectives, are the material collection and processing and the laboratory testing. In particular, the last one is installing the recycled thick wall tubing at Fresno State. The Fresno State farm has a substantial amount of vineyards, and they have a portion of those vineyards that are regularly removed so that the students can see a set of vines in various stages of development, from initial installation all the way up to about 5 or 6 years. So we have this area of the vineyard which is regularly being monitored and replaced by students who are keeping an eye on things throughout the season. That gives us an opportunity to do a long-term test where we install these tubings in a place where the students are going to see them. The tubing itself isn't removed every 5 years, so it'll be out in the field for 5 to 10, perhaps longer, and it'll be regularly inspected by the students. So that's where we are with this project. It's still a lot to come, and we're still very excited about it, particularly if you've been following the news. The California Attorney General just initiated an investigation into the plastics recycling and some alleged misinformation in that regard. So this project is particularly timely because we're addressing both the technical and economic aspects, and hopefully the results of this will actually add some clarity to that conversation. So I'm happy to take any questions if there are any.
Again, I'll say, please just speak up or raise your hand to chat, but just join in if you have a question for.
So I see a question from Amy. Will the project consider anticipated footprint emissions associated with freight and transport? The economic analysis isn't looking at carbon impacts in particular. We'll be looking at transportation costs generally. I can bring up the enterprise budget if you'd like to see some of the, let's see, the variable costs. And it looks like Dr. Askey did not call out fuel separately. So the answer to that question then would be no, we wouldn't be looking at carbon footprint in particular. And I see a comment from Eric Olson that they will be picking up the field tape in about 2 weeks from now.
Well, thank you all. Thank you, Charles. That was very interesting. We're the IIC is, of course, very interested to learn how this project goes. I see one last question here. We have time for one question if you want to address that one in the chat, Charles.
Sure. So the question is, was any testing done on the drip tube made of with recycled material for their ability to hold drippers? So the testing hasn't actually occurred yet. The battery of tests that we have does not include the ability, I assume what you're asking is the ability of the emitter to stay affixed to the tube itself. All the tests that we run are based on existing standards, and as far as I know, there's no standard test protocol that would measure that in particular. So the answer to that question then is no, we won't be looking at that specifically.
Well, we're looking forward to the study, Charles, and how it proceeds. And we appreciate Jane is here and they're supporting this. We appreciate that as well. So with that, let's move to our next presentation. And at the end, y'all, we'll have a bit of time for overall questions. So put your questions on hold if we've moved on past that speaker, but we'll have time, to circle back and have some discussion amongst the panel and the speakers. So with that, let's go to our next investigator, Trenton Franz. Trenton, would you take it away, please?
Great, thank you, and nice to see everyone. So today we'll be talking about a new irrigation algorithm that we developed in a previous project, and now we're testing it out in the real world. So exciting to put some of our theory and model actually into practice. And so the main motivation is to find some irrigation solutions that are scalable, deployable, and cost effective. And I'll talk about that here in a second, what I mean by that. Next slide. So before I get into the research, I just want to share a little bit of past experience from some of our work within Nebraska. So in the past, I've participated in 2 technology cost share programs with the Nature Conservancy and our local natural resources districts. And so basically these 2 different projects in western and central Nebraska introduce and train producers on things like using pivot telemetry, soil moisture sensors, weather stations, and then geophysical mapping for things like variable rate irrigation. So in western Nebraska, we had 30 producers in the historical data. In central Nebraska, we had a more robust designs. We had 50 producers, as well as 10 control fields and a good partnership with the NRD. And so as part of that project, we recorded applied irrigation through flow meters and as well as their crop yield. And so we looked at comparing historical trends and control groups to those technology groups. Next slide. So I'm not going to get into the details of that project, but the main upshots is that in terms of the technology, we found that after the cost share ended, about 95% of people kept their pivot telemetry, really just for the convenience of that. So this was a very sticky technology. Well, unfortunately, we found that only about 10 to 15% of people kept their soil moisture probes or weather stations. And really the main sort of comment back from the producer groups and focus groups was just really wasn't worth the hassle to manage those probes. So thinking about a little bit about the economics of soil moisture probes, in western Nebraska, we found that you could save about 3 to 4 inches of water, depending on the year. In central Nebraska, a little bit wetter, and so you're looking at more around 1 to 2 inches per year of water savings. So a typical probe will cost about $1,000 per year. That varies quite a bit. We didn't find any measurable yield difference in these experiments. And in terms of energy costs, which is the most sort of direct benefit, is that in Nebraska, it costs about $500 for every inch of water over a 130 acre field. So in order to pay for the probe, you need to save about at least 2 inches of water in terms of the energy savings. In terms of policy implications, so it seems pretty clear that soil probes are very useful in drier areas, but there's still some benefit even in central Nebraska. Also, in terms of the policy, the ability to stretch out a multi-year allocation is extremely important. Actually, Darren and I were just discussing with Jesse Bradley this morning through the DNR about how most of Nebraska's water problems could be solved if each field could just save 1 inch of water for about 8–10%. So that was an interesting conversation this morning. Next slide. So in terms of the soil moisture probes and the history of that, this is pretty well known, as there's some nice farm and ranch surveys going back to the early 1980s. And basically the soil moisture adoption rate hasn't changed over the last 4 decades. It's really stuck at around this 10% number. Next slide. All right, so our IIC project was trying to overcome some of this barriers of adoption. And the nice thing with this project is we were able to work with the scientists from UNL TAPS in North Platte, Nebraska. If you're not familiar with that project, it's a really nice competition that brings together UNL scientists, extension professionals, producers, industry leaders, students, government regulators, and agency personnel. So it's a highly engaged network focused on evolving profitability and input use efficiency. And it's really a low risk environment that offers participants the ability to test as well as receive training on a large number of different strategies and technologies. And so I think they're going into their fourth or fifth year now with this program. So we were able to couch our experiment within one of these individual competitions, which was pretty neat. Next slide. So, what we did for the experiment is we first wanted to set up some independent validations. So we stuck in some weather stations. These are the Arable Mark IIs, one of our project partners, as well as Centec soil moisture probes. And so we put this experiment in an irrigated corn site. So we had 3 different blocks and 6 different types of experiments. I'm not going to go too much into the details, but this is just an overview of what the pivot looks like in each individual block. Next slide. So the algorithm that we were testing was recently published. This is the paper that came out last year. And so basically how the algorithm works is it's taking both water supply as well as atmospheric demand and combining that into a new approach for doing irrigation scheduling. So this is going to be a modification of the max management allowable depletion scheme, which is widely used for soil moisture probes. But in addition to that, we also take into account things like the vapor pressure deficit and basically the atmospheric demand on that day and modifying this MAD approach. Happy to go into more details if there's time after the presentation. Next slide. So from that paper, we were able to validate this, at least in the modeling world, where we had 20 different site years, 12 different sites across Nebraska, where we looked at this MAD standard approach versus this new approach we call SDD. And what we found is, at least in the model space, we reduced irrigation by 24% over these 20 years. We didn't see any difference in crop yields with this approach. And in terms of looking at the economic profits, we had an 11% increase and an increase of 25% in terms of irrigation water productivity. So at least in the modeling world, we were very happy with this results. Next slide. All right, so putting our money where our mouth is as we apply this algorithm to the UNL TAPS project. So this is pretty hot off the press. These are the initial results from 2021. So the graph on the right shows all of the different participant fields. We have our productivity function, we have our irrigation versus our grain yield. And so farm 29 was the winner of the competition for being most efficient, shown by the red dot there. And what you see in the productivity function is you have a nice second order curve or a broken stick kind of linear model. And so there's a nice break point in terms of irrigation versus grain yield around that 9 inches and 225 grain yield. And so what were the results of our experiments? So we ran 2 different SDD approaches with different sort of aggressiveness in terms of that approach. And so we came in pretty close to what the UNL scientists got for their ET model, as well as 125% of the ET model. Next slide. So we were pretty happy that we got really close to the other UNL scientists that were running an independent experiment. How we compared against the producer groups, we did okay. We were kind of in the 30 to 40% quantile. So we beat some producers, but we were kind of around that just below average in terms of water efficiency. Next slide. So just summarizing this experiment. So compared with the ET approach, both the SDD approaches saved irrigation water use. So we were happy about that. We didn't really see any differences in maize yield penalties, so no loss of yield. In terms of water savings, we had The more aggressive SDD2 approach saved about 5.1% water, as well as increased profits by about 5%. So getting close to sort of the uncertainty within the experiment. But overall, we were very encouraged by this first attempt. Next slide. So summarizing, so the SDD approach is driven by Mesonet weather station, which is widely available across the state, again, using things like vapor pressure deficit and rainfall. A simple water balance approach run by our collaborators at University of Illinois, and this SDD algorithm that was developed. So in terms of the SDD approach, the yield, irrigation, profits were similar to our local ET model run by the UNL experts. So we were excited to see that we were close to that crop productivity break point of around 225 bushels and 9 inches of water. And so that was really critical that we were close to that optimality point. In terms of yield efficiency, again, we ranked just slightly below the average, but we're very encouraged by our initial results and looking forward to the 2022 season. And lastly, this approach will be published, all of the results, but it is working with scientists from University of Illinois, and this technology has been licensed out to one of their spin-off companies called Habitera. With that, happy to take any questions.
So Trenton, I see there's a question in the chat. If you can see it from Amy Harsh.
Yeah,
Go ahead and take that one if you would.
Sure. In my experience, if used properly, probes do equate to measurable yield differences. What is your definition of measurable, and why do you think there is no measurable differences? So this was just going off of the yield monitor. So we got the output from the farmers, and so it was looking at really an average across several fields, or we did have some with the TAPS project. We did have the rain fed and the other sites. So yeah, we did have some controls on that experiment. In terms of the modeling paper, the SDD approach was coupled with a crop model. And so that was looking at scheduling with the MAD approach versus this SDD approach, and looking at model differences in yield. So a couple of different ways to make that claim. So thank you.
Could you address just briefly that last point you made about the intellectual property or some type of patent? How does that work vis-a-vis the future of this research?
Yeah, so like I said, this algorithm was developed by scientists at University of Illinois. And so the Illinois has decided to license off that technology, and the company started by one of those scientists has that license. And so that's where it resides. This work is in collaboration with that company and University of Illinois. So we will be publishing the results of that. But like I said, the algorithm lives with the IP at UC.
But obviously the results of the work, the approach, all of that will be fully published and available to the public. Yeah, okay. Well, we look forward to that. One more question and we'll move on to Dayle. Is SDD broadly applicable to a variety of crops?
Yeah, I think so. So we just developed it for corn and soybeans so far. But I think it's basically a modification to that MAD approach. So as long as you know those kind of, what percent of depletion that you trigger irrigation, it's just simply modifying those based off of the local vapor pressure deficit. And so those thresholds of when you trigger that and how you tweak that are still being worked out with this experiment. So certainly it is applicable, but I think those triggering points need some additional crop modeling or even some infield studies to kind of really refine those. Thank you.
Very interesting. Thank you, Trenton. That's we look forward to working with you this year on this project and finalizing the results next fall. With that, let's move to Dayle McDermit. Dayle, would you ready to go? And can you take on the next presentation, please? And we'll have, so you know, we'll have Dayle, if you can finish up around 12 o'clock our time, 1 o'clock your time, we'll have time for a little bit of discussion amongst all the presenters. So
Okay.
take it away. Thank you,
All
Dayle.
right. Can everybody see my screen?
Yep.
Okay, good. Well, I'm going to talk today about using field scale electrical data to estimate real-time water delivery with center pivot irrigation in central Nebraska. I'm working with Billy Tiller and Mark Cox of Grower Information Services Co-op, Amy Novak Harsh of Nebraska Water Balance Alliance, and Bradley Dayle, who is a grad student at the University of Nebraska, and Aaron Hacker, an assistant professor in geohydrology at the University of Nebraska. Bradley developed some of the data that I'm going to present here today, and it's part of a master's thesis that he completed this spring. I'm an adjunct professor in agronomy and horticulture at the university and a board member of the Nebraska Water Balance Alliance, and I'm also working with the Doherty Water for Food Institute as a faculty fellow. So our study is looking at water management in the Twin Platte Natural Resource District, and the Twin Platte NRD is home to the South Platte River, the North Platte River, and the confluence of the two to form the Platte River system. And in 2004, the Nebraska legislature designated portions of the Platte River system as overappropriated, and groundwater irrigation was reduced to the stream, reduced stream flow. In 2009, the Twin Platte NRD developed an integrated management plan to reduce groundwater irrigation and stabilize stream flow. The first increment of that plan ended in 2019 with planned delivery of 7,700 acre feet per year to the Platte River stream. And the second increment will end in 2029 with the planned delivery of 25,000 acre feet of additional water to the Platte River system. So we can't manage what we don't measure. And so the Twin Platte Natural Resource District developed a water data program. The goal is to provide growers with real-time water use data, and also to provide information that the Nebraska Department of Natural Resources will use in water models to evaluate the effectiveness of the program. And the Twin Platte NRD believes that accurate data in the hands of producers in a timely way will reduce groundwater use, and this is a expectation that has been seen elsewhere also. So the water data program is organized around an application called Ag Hub that was developed by Grower Information Services Co-op, and Ag Hub has three inputs. The first is metadata that is collected from the NRD on each of the center pivot irrigations in the resource district. Also a portal for signing up irrigators in the district. And then thirdly, a portal for receiving electrical runtime data from each of the registered wells and using that runtime data to compute water delivery. That information is then presented back to the growers on a daily basis using an app that runs on a cell phone. And also data are integrated, aggregated by Sitka Technology Group, and then returned to the Twin Platte Natural Resource District, the State Department of Natural Resources, and Olson Engineering, which is helping with the data management. So this shows center pivots in the NRD. There are over 313,000 irrigated acres in TPNRD, and well over 90% of those irrigators are signed up in the system today. So a simple solution for measuring center pivot water delivery is to compute pump runtime from electrical runtime data, and then we estimate water delivery as the flow rate times the pump runtime. Unfortunately, this requires knowledge of the instantaneous flow rate, which we don't generally have. So instead of using the instantaneous flow rate, we do a flow test on each well and use that flow test output as a calibration, constant calibration factor, and then use that times pump run time to compute water delivery. So this system has the advantage that it's simple. Electrical usage is already collected by power companies at 15-minute intervals. The data are secure and immutable because they're used to calculate the electric bill for every grower, and the data are readily available. The method is inexpensive in as much as flow tests are not required very often, once a year or less, and they're relatively inexpensive, costing $200 to $300 typically. The data can be made available daily, every day. The grower will have an update on the amount of water they use. And most important, no other meters or data are needed to make these estimates. So the big question is, how good is the approximation of using a flow test versus instantaneous flow rates? That's going to be the subject of the rest of this talk. And I want to emphasize that the work that we're doing here is sponsored by the Nebraska Water Balance Alliance in cooperation with GISC, but this study is independent of the water data program that's being operated by the NRD. So our study site is located in the Twin Platte Natural Resource District south of Sutherland in Nebraska. And it consists of two groups of wells of 5 wells each, and 2 wells in each of these groups was equipped with a micrometer flow meter that's capable of telemetering data back to GISC at 15-minute intervals that are coincident with the electrical runtime data. We also drilled some observation wells adjacent to the monitored wells and a monitoring well that it was outside of a center pivot, but I won't have time to go into those results. So looking at the flow rate calibration measurements, a flow test was performed in all the wells in the fall of 2019 by a vendor I'll refer to as vendor A. And then they repeated those flow tests in September of 2021 at the end of the growing season again. And then we had a second vendor, I'll refer to as vendor B, who did 2 sets of flow tests on each of the instrumented wells in 2021. When these flow tests were performed, the vendor would apply the ultrasonic flow meter and read the instantaneous flow rate, and simultaneously I would read the digital output flow rate on the micrometer flow meter. So these are simultaneous paired measurements. This shows the results of the comparisons of the flow tests with the flow meter measurements. And first of all, looking at the rectangles, those rectangles represent vendor A, and the open rectangles show what happened in 2019 versus 2021. And you can see the agreement over the 2 years was quite good in most cases, with the exception of this well here, P12, where there was a mechanical failure in the well during that time interval. And so these data will not be considered further. And we also see that the comparison between the 2 different vendors, the agreement between the 2 vendors was about 5%. Also, depending on when the flow test was performed, we could see up to 7% variation depending on the position of the center pivot at the time the flow test was performed. And finally, we have this one instance down here with pH2, where all of the flow test measurements are about 6% below the flow meter measurements, suggesting that that flow meter may be reading high. It's unlikely that 2 different vendors with 3 different operators over 4 different times would all get a flow rate that is below what that installed mechanical flow meter was reading. So we're interpreting this as that flow meter reading high. So this shows the seasonal water delivery for well T4. The dark blue points represent the reported water flow rates from the flow meter. And these bars represent the estimated flow rate from the electrical runtime and flow calibration tests. These fields of points down here represent partial 15-minute intervals at the beginning or the ending of an irrigation event. If we plot the estimated volume against the measured volume measured with the flow meters, we see that the agreement, our method of correcting for beginning and ending values really work quite excellently well. And this shows the field of points for all the measurements over the season, with the vertical variability being due to the variation in flow test values, the horizontal variation due to variation in this well as the center pivot traverses its circumference. So this shows the impact of end gun operation and also topography. So when these solid bars in the center pivot map are, these bars represent times when the end gun is on. Here, the end gun is off, and we can see that in the power data. The gray bars are occurring when the end gun is not operating. We see a power drop, and we use this power drop to actually make a correction for end gun operation. Also, if we look at the instantaneous flow rate values from the flow meter, we see a repeating pattern here, and this pattern can be mapped to the topography change as the center pivot traverses the circle. Now, this is a fairly large variation. It's about 10% peak to peak, or mean plus or minus 5%. It looks quite large. If we put that in perspective, this is the same data from pH2 over the season. We can see the fluctuation due to topography, the estimates from the flow rate data. And this shows that generally our electrical run times are underestimating the flow rate measured from flow meter, but we believe this is because of a calibration issue with the flow meter, not the flow test results. So overall, for the entire season, now looking at the integrated accumulated water measured by the flow meter or by the different flow tests from vendor A and vendor B, we see, generally speaking, the agreement is within 6% or better, except in the case of pH2, where both of the vendor estimates are substantially below what the flow meter estimated, but we believe that is due to flow meter calibration. Okay, so last, in summary, this method is highly scalable. It is simple and robust. We believe the results are accurate and timely. We're putting information in the hands of the growers on a daily basis when they have time to act on it. And we think being able to measure actual water delivery is important because we're seeing very substantial aquifer declines throughout the many portions of the High Plains aquifer. And here in Nebraska, even where we have a blessing of good groundwater availability, we still have stream flow issues that need to be managed, as well as groundwater depletions in certain areas of the state. So with that, thank you.
Dale, that's a lot of work you all are doing there. It's quite an interesting application. I've got a couple of questions, but I want to make sure that I don't jump in here. Does any questions in the chat, or anybody want to just jump in with a question? So I'll stick a question there and we'll see where it goes. But you addressed some of my questions, or some of the interest I have early on in the presentation, but I'd like to explore a little bit more, which has to do with how you and your team see this as being effective. What do you think the impact might be? As you said, putting information into growers' hands leads to something good. And what do you anticipate that? I saw you had 92% of the acres in Twin Plat are registered through this program. Did I see that correctly?
You did, and actually the number's probably higher than that.
And that
At this point.
equates to, I don't know, about 300,000 acres of registered growers that are involved in this. So I'll ask two specific questions. One, how much difficulty is it to get those growers involved and just overcoming, if you will, the perception about sharing their data and things like that? And secondly, what is their incentive? What do they get out of it? Where do they see this being advantageous to them?
Okay, well, I'm going to ask Billy Tiller to answer the main aspects of your question. But before I send it to Billy, let me just say, when I water my lawn, I can hear the flow meter in my basement, the water meter clicking away, bang, 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 bang. And you know, that makes me think, man, I don't want that thing running any more than it needs to. And the Twin Plat NRD has the same opinion, that when a grower can actually see what's going on, it'll make a difference. And with that comment, I'd like to turn it over to Billy Tiller. And Billy, would you like to address those 2 points?
Sure, I'd love to address it. So first of all, we're down to 2 growers that haven't signed up. Now, I understand that it is mandatory as of May 1. We had about 85% of the growers signed up before that kind of came to knowledge. So there's always a group that, again, Tim, you said are worried about what's going on with their data and what's happening to it. One thing that works very well is that GISC is a data co-op owned by its growers. We're well known for data privacy and protecting the data of the growers. So we check that box for them when they go and really look at what we do. I mean, I sit on something called the Ag Data Transparency Board, where we monitor companies all over the US and certify them. It's what they do with growers' data. So if you were to look at our agreements, they're very short, they're very sweet. They basically say, if we're going to do anything with your data, we have to ask permission. You have to check a box. You have to have thorough understanding of what's going on with that. I will say this, to get a project at this level of adoption, you have to have a partner in someone like Twin Plat NRD, someone that's committed to the farmers, and they've went to them and I went with them. So we've created a scenario where we're talking to them, explaining to them the benefits of more information, what that means to the modeling for Twin Plat, better information, because I've convinced growers that, you know, if you want to be regulated with incomplete, perhaps erroneous information, then you're going to let them do that. But if you want them to actually implement programs that are sound, they have to know and understand what's happening today, not in 20 years ago when there was some data collected. I could go on and on about this, but I do want to say one thing about a gentleman named Dr. Guy Phipps. He's a researcher, an older researcher from the Texas A&M system. He was very involved in the lower Rio Grande Valley. I read an article by him early on where he said in 2000, he was doing work with those guys when he began to let those farmers see how much water they were using, because most farmers underestimate what they pumped any given day, any given week, any given month. When they saw those numbers, he saw numbers drop 10%. And so I went to him, and I actually had a call with him 3 weeks ago. We finally made connection. And I said, I have to understand this because I'm seeing similar things. And he said, well, it's just, and they said, I saw it over and over and over. So there is, in the first instance, just a reflection of turning that pump off. And Dale's alluding to that with his lawn experience. Same thing, one quick story from one grower. He said, well, I'm worried about when I'm watering. I want to shut it off when I don't need it. And I said, well, how do you do that? Help me understand how this is helping. He said, well, I'm cognizant of the fact this water's a gracious resource we're given. I want to do the best with it. So he said, I think I'm saving an inch by just every time it rains. He doesn't have any electronics, but he gets up and shuts wells off when it's raining. He said, I think I'm probably 2 or 3 hours earlier every time shutting them off. I don't wait till 7 in the morning. I go at 3 in the morning because I want my water to look good. So anyway, I think that's part of what goes on. We all know what will happen in the coffee shop. Farmers talk, they like to talk yield. And so what's going to happen now when they're talking about, we're going to work on some benchmarks. That's the next step, where a farmer says, I am the 83rd percentile. And another guy knows he's in the 30th percentile, but he's not going to speak up. But in his mind, he hates that he's getting beat by his neighbor. So he's going to get out. I really love guys just a moment ago talking about soil moisture probes, trying to get adoption of those, because I think that's the next step. putting those things in. So I'm going to stop there. But there's so many interesting things get integrated together. We can really make a massive change here.
I agree. And the percentile issue that you mentioned, I think that's a tremendous idea, but you can't do it unless you know how much water you're actually delivering.
Good point.
That's the key. You just cannot manage what you don't measure.
You're
So
right.
I've got another question, a hand up there. I'll just make a point, Billy. What we're looking for, I guess, is the metric here is when the coffee shop talk is not about yield, but it's about water productivity. Yeah, I got a water productivity. You're a water. I'll buy coffee for the guy who has the best water productivity. That's when we've made some progress. So with that, I'll go to Charles, please, Charles.
Thank you. So what I have is more of a question or a request than a question. So I think we've talked in the past about a company in California that's doing something very similar to what you guys are proposing,
Yes.
or what you're actually doing. However, what you're doing is being done in a way that's a lot more transparent. Right?
Yeah.
They're a private company. They need to protect their IP. It's understandable that they would hold some things back, but you've got it all out there. What you're working on and what that company in California is doing is of great interest in California because of our Sustainable Groundwater Management Act, and everybody needs to be able to measure their flows. And so this is a great opportunity to have a cheaper, more scalable way to do the flow. However, the uncertainties associated with flow meters, particularly the inline flow meters that that most people use, uncertainties around that are very well understood. This is a new method. It's going to have different kinds of uncertainties associated with it. So I'm putting something in the chat window, and this is my ask, is that if you guys have a chance, take a look at this standard. This is the same sort of conceptual framework that we use to analyze the uncertainties in flow meters. It's what gets applied in the international standards for measuring the performance of flow meters. And if you can express the uncertainties associated with this method using the accepted framework for doing it, it makes this a lot more viable. And that would be beneficial to you and to this company, which are, my understanding is they're doing something in a not exactly, but very similar way. So if you have time for it, that would be a great benefit.
Great. I'll look forward to looking at it. Billy, go ahead.
Well, I wanted to make sure you saw that link, Dayle, because Charles, I applaud you on that, because I think that's exactly what we want to do. I will tell you this. Yes, it is a private company, Ag Monitor, Olivier, and I wish I could pronounce his last name, but it'd be terrible. But he's a French descent, great guy. Him and I have had lengthy conversation. In fact, this week I had an hour conversation with him. So we're trying to understand actually how we could even integrate some of their ideas. He's very transparent with me. I got to be honest, Charles. I applaud him. Of course, we're a co-op. I don't need to steal someone's idea. I could license it. I could use it. I could integrate it. I could become a reseller. He does really well in helping farmers understand. I'm going to call it predictive analytics. He's going to be able, I believe, to help me tell a farmer when a well's going to fail, maybe a month in advance. Those are powerful tools for an irrigator in Nebraska. And look, if a well's pumping inefficiently, and he can notify us of that, those are things. I want to save those greenhouse gases. I want to get back to saving kilowatt hours. So I thank you for this link. We'll take a hard look at it. And yeah, if I could further that, I would share that with Olivia in a moment, because we just need this to scale out. I don't want to own it all. I'd love to see 10 other companies doing similar things, but you got to manage the grower, and y'all are catching on to that. And I do appreciate, and what I mean, manage the grower, you have to meet expectations around his privacy. And if we can't do that, a quick comment about the Twin Plat NRD program. We do not share individual data with the state of Nebraska in any form. Early when this project started, I sat down with him and said, I cannot bring growers into a project knowing I'm turning over all the data. I'll lose them as soon as they understand. You got to accept aggregated data for the whole watershed. They did. They accepted that. So that's a critical piece. We have to learn to manage that to get farmers to put that data out there.
We're getting short on time. Dayle, do you have a very brief response to B. Johnson's question?
Yeah, I was just about to speak to that. We're taking advantage of the new technology that is made available through electric smart meters. And I don't know. Do you see this question, Billy?
Yes, I do.
Okay, I think this is problematic if we don't have the smart meters available, but what are your comments on this?
Well, my comment is what's unique about our transparency and how we do it. If I was using kilowatt hours, if that was the important component, you're spot on. But the important component to me is that our algorithms that run identify the periods that have irrigation. Are they partial periods or full periods? So I'm really looking at a clock. It's not going to change the clock because we're looking every 15 minutes at a block. There's 96 of them in a 24-hour period. Was he irrigating? And then we apply the flow rate. And there's an algorithm for end guns and all that. But and the only thing we use the electrical data for is to say, oh, switch is on. This is irrigation. And look, irrigation is 10 times what it is to walk a pivot in most cases. So it's very easy to notice, is he walking or is this real irrigation? Even with variable rate drives, I actually have one instance where I've worked with one particular grower. He has variable rate drives. We're looking at that, but I don't even think we're missing any intervals. Because we're using a pretty small number that's just over the walking of a dry pivot. So I'll stop there, but I think that might be the answer to that, but it's something we need to continue to look at and worry about variable rate drives or recapture.
Yeah, I really think though that being able to capture the data in real time is an important thing. Using accumulated electrical data at the end where you're looking at the magnitude. Well, maybe if you have electrical runtime, that might be okay, but it's much better if you have the 15 minutes.
It is a good point, though. There's a lot of issues around variable rate drives and how you monitor and measure. So it's something as they grow, they're becoming increasingly more out in every area we're looking at.
Yeah.
Well, thanks for that discussion. For questions or comments, just discussion for the previous speakers. Anything from our chat? I think we have a 15 stop time. Is that right, Susie? Okay.
Yeah, that's right.
But 12:15. Nobody starts a meeting at 12:15. So I guess that was pretty clever, Susie, to set it up end at 15. But I don't want to drag this on. But I would maybe go back to Trenton, and actually it relates to at least the three speakers, all of us in some form. What's your thoughts on full moisture probes? Trenton, you mentioned in your presentation that we have a 10 to 15% adoption retention. What's your thoughts on that in terms of not so much the science, but in terms of the adoption side of it? What do you all think about that?
Yeah, so I think, soil moisture probes need to do three things, and they need to be accurate, easy to use, and low cost. And unfortunately, most technologies can only meet two of those three criteria. And so you're kind of giving up one of those dimensions of, effective soil moisture probe use. And that's, just some of the challenges of the technology. There's other ones I've seen that are coming online that can help overcome that, but it's still a technological and just use of the probe challenge. So
also, this is a field that you work in as well. What's your thoughts on adoption, on uptake? What's the hold up?
Well, I have some opinions, but I've noticed that there's someone, and I hate to put somebody on the spot without giving them a lot of advance notice, but there's somebody on the call who actually was doing sales of probes in the Panhandle around the same time I was. And David, if you wouldn't mind, could you comment on some of your experiences in what it's like getting growers to adopt probes from a manufacturer's or vendor's perspective? Is that something you feel comfortable doing?
Sure, thanks, Charles. So for those who don't know me, I work for Grow Guru. I've last 3 years. I used to work for Aquaspy before that, and introduced Aquaspy to Panhandle of Texas and surrounding areas. Kansas, Colorado had a big hand in supporting probes across other parts of the country as well. Been in the industry for 25 years. Some of the barriers to adoption are, yes, cost is one of it, but it's getting the dealers to support it. It's I find, I mean, yes, there's always pushback on cost, but that's never the main reason. Farmers are always cheap. It's the ability, it's the time factor of having to install and remove probes, and it's that scalability factor that really is one of the biggest barriers. So, you know, people who are in the industry, and there are others on the call who are involved in one way or another, who can, they can put out, they try a year 10 or 20 probes, great. They go to 50 in the next year, and they get to 100 maybe. And one consultant can only put out 100. They then have to employ another person, and they may get to 200, but they never get further than that. And so co-ops and irrigation companies, everyone else in the industry are busy in June when they're trying to put probes out, and nobody has time to go and do it. And that's been one of the biggest barriers, which is what we've been focused on at Grow Guru, is leaving them in a permanent way. And so rather than trying to get them in and out quicker, we just put them in once and farm over them. And it doesn't fit all situations, but that's what we're working on. And so in another forum, I'd love to explain that to people. I realize that now's not the time, but you know, I see the scalability factor as one. The other one is education. All too often you read probes using graphs, and that's where the data is delivered. That's where the sort of the truth is, but people don't know how to read graphs. Graphs are to irrigation scheduling like an X-ray is to a doctor, or an ultrasound, or an MRI. You have to look in the root zone, you have to know what's going on, but nobody knows intrinsically how to do it, so you have to be taught. Now, a lot of people aren't capable of learning. Some people don't want to know, and so that's the other part to this, is making it super simple. And we're working on that too, with using artificial intelligence to pick out signatures in the data. But once again, I don't want to hijack things on a commercial basis. Hopefully that answered the question. I'm open to follow-ups.
I don't want to, you know, don't need to dominate on soil moisture probes, but I just think this is a very interesting kind of sort of common point amongst, you know, these discussions, because it has to do with, you know, technology and, like you said, education, demonstrations, you know, and Trenton's, you know, I didn't write down the numbers, but there was like a 10% savings of water. Water is $500 an inch in energy costs. I mean, you just do the logic, and it says, man, if you can save water, you can save money. And if you can get the same yield and you can save money, there's something wrong with this equation, and we need to keep working on it.
So I see that it's going to go mainstream when you can start to automate things. And that's hard to do with the current technology, which is why we're working on new technology. But just because of the scalability and the fact that you remove a probe, you put it back in, everything shifts. So, but if you can, people like set and forget. It's like, you know, irrigation systems on your front lawn. Nobody ever goes and plays with that every day, unless you're like me and you mess with it. But that's the way you're going to get major savings. And the adoption is largely driven by the people that are taking the time to really understand it. But there's a lot of people that just aren't willing or aren't capable of being taught.
Yeah. Well, thanks for that discussion. I mean, this to me, it kind of represents the essence of what the IIC is attempting to do and is involved with. So that's why I say it's not our only topic, but it has all the elements of what we think are important and how we can be instrumental in moving forward. So Dayle, I see Bill's got his hand up, and we'll another point or two.
Yeah, to kind of pull this together, Tim, I have a question for Trenton and Darren, who I saw was online also. If we have good models for calculating evaporative demand, and we have ready methods for measuring precipitation inputs, and if we can measure water application in real time reasonably accurately with the methods that Billy and our team are putting together, can we not do a close enough approximation to a water balance? If we start with a full soil profile, for example, can we get close enough to do this in an automated way to give a grower a pretty good idea of when they need to irrigate. I mean, you know, I started with this much water. I'm using 0.25 inches per day, say, or whatever the number is for ET. And I got 1/4 of an inch of rain last night, and I'm irrigating at a certain rate. I should be able to calculate the water balance. So it seems to me that this is a technological issue that is addressable, even if we don't have soil moisture probes. In this case, soil moisture probes become kind of the independent check on the rest of the system. And that's nice, but maybe we could relax the need to have them.
Yeah, let's take a response or two to that, and then we'll wrap it up. Any points?
I'd love to answer that real quick. And I think that it's both. I think you use modeling and sensors, and I think that modeling will stretch beyond the sensors. So let's say you've got 10 fields. If you've got sensors in 3 or 4 of them, you can model all 10 of them. And
Totally agree. Yes.
Yeah, just add that, you know, kind of like with weather models, is those small uncertainties and errors grow over time. And so you got to reset that system, you know, over time, just like in weather models, because those errors just grow. So, you know, in 7 days from now, you know, your current state or your predictive state may be off, and you got to, you know, reshuffle that back to being in a good state space to get to nerd out a little bit here. So,
Yeah. Well, that's a good closing point then. Thank you, Trenton, and thank you all for this discussion. I'm real impressed. We went overtime 10 minutes, and I don't think we lost anyone. So thank you everyone for hanging on and staying with this discussion. Like Aaron, oh, that's either a goodbye or a hand up. I think that's a goodbye hand. So bye, Aaron. Thank you all for coming. I think this was a great session. I want to say thanks to our 4 presenters and to all the work and your teams are doing. And we're making progress. I feel really good about the bulk of the work that we're doing. And I want to thank you all for your contributions, which are going far. So with that, Susie, unless you have something else to say to our participants here, we'll close it out.
Yeah, just to add on to what Tim said, we're just so proud of all of our PIs and the work that they've done, standing up this really, really valuable work for the irrigation industry. So thank you all to our PIs. Thank you all to everyone who stayed on this long and participated to the discussion. Yeah, we are really proud of everything we're doing. Yeah.
Yeah, sorry. One very last thing, Susie, in case we didn't get to a question or two in the chat, we'll make sure that we get back to those. There was 1 or 2, I think, that might have slipped through the cracks. So we'll make sure to get those addressed by the speakers. So
Yes.
with that, thank you very much. We're gonna fade out, and you all come to irrigation.org, irrigationinnovation.org, if you can or if you need. Thank you so much. Thank you again, Susie.
Yeah.
Thank you all.
No problem. Thank you guys.
Bye.